Hey everyone, welcome to another episode of Let's Lead. Today we'll be talking about one of another classical problem that is minimum ASCII sum of two strings when we delete or try to make them equal. Okay, so this is how actually what the problem states. Let's say I have two different strings. One is for example C and other is for example eat. Okay, so I need to make them equal. And while making them equal, I need to make sure that I delete only that many characters from either of these strings or both of them, which gives me the minimum ASCII value when they are summed. For example, what I mean by that is if I talk about C and if I talk about eat, okay, if I delete S from here and T from here, okay, then these two characters will be equal and the resultant ASCII sum would be S plus T. So this is the only way to make them equal, and this will give me the this is the least deletion I need to make at least to make them equal, and whatever the ASCII sum of them will be our answer. Okay, so to approach this problem we'll be using the concept of dynamic programming. Dynamic programming is basically when we try to solve a problem by breaking it into its subparts, and we treat those subpart as an independent problem in itself. What I mean by that is, for example, let me draw let's say the length of this string is m and the length of this string is n. So what I'll do is I'll draw a matrix of m plus 1 and n plus 1 size. What is the intuition behind it? You will understand it in the future when I'll explain it. But let me draw m plus 1 and n plus 1 size matrix. What we will do is I'll write both of these strings, one on column wise and one row wise, leaving the first as blank. This is the blank. Okay, I'll write eat here, I'll write C here. Okay, let me highlight this. This is eat, this is C. Reason behind writing these characters in this way is we will treat each cell as a independent subpart, and each cell will represent the cost or the sum of the ASCII values of deleting the minimum number of characters to make those those characters or those characters equal. What I mean by that is, let's say if I talk about this particular cell, okay, now this will represent me the cost required to make EA and S equal. Okay, and S equal. So this will represent the cost required to make EA and S equal. So what will be the result? We need to make EA and S equal. What we need to do is we need to delete E, A and S. In that way both will be blank and will be equal. So this will be E, A and S deletion. If I talk about this cell, this will be the cost of making EAT equal to blank, and that will be deleting E, A and T. In this way, this particular cell will give me my answer. Okay, so let me revert it back. We will start off with the first cell itself. Now in the first cell, this we need to make blank and blank equal, so there will be no deletion. This will be 0. From the second cell itself, we need to make E and blank equal. We are still in the first row, so keep in mind this will be blank. We need to make E and blank equal. In that case, we need to delete what? E. So I am writing this in character format, but just to make it easier, but just consider the ASCII values of these particular characters to understand the cost which will be represented in that particular cell. Okay, so the here it's not E, but instead our code will store the ASCII value of E here. Okay, now moving forward, this we need to make EA and blank equal. In that case, we will delete E and A. Next, we need to make EAT and blank equal. In this case, we need to delete E, A and T. So understand the pattern here. Okay, in the first row and in the first column, we'll see on later. As we move forward, we are adding each character one by one. Okay, in the next cell. So here, why I'm saying this is we will use this pattern in our programming, in the program we write. Okay, so E here, in the first cell it's 0. In the next cell it's 0 plus E. In the next cell it's E plus 0 plus A. In the next cell it's E plus A plus T. Okay. Similarly, if I talk about the first column, I need to make blank and blank, so it will be 0 here. Then I need to make blank and S equal. So in that case, I'll have to delete S. In the next case, I need to make blank and SE equal. So in that case, I'll write S and E here. Okay, it's the cost basically, the sum of S and E, the ASCII sum of S and E. And here I need to make SEA and blank equal. So in that case, I'll write SE and A here. Okay, so moving forward, now talking about this particular cell, here I need to make E, okay, and S equal. So I'll have to delete both E and S. Okay, now here I need to make EA and S equal. So in that case, I'll have to delete S, E and A. In this case, I'll have to delete EAT and I need to make EAT and S equal. So I'll have to delete SEAT. Okay. So this is the pattern. Talking about the next cell. Okay. Understand one thing. If you see the pattern here, if there is the cost involved or the adjacent cells are same. Here E and S and S and E are same. In that case, we can directly the diagonal value will be directly placed here. Why? Because just see, this cell represents the cost of making E and SE equal. In that case, only S needs to be deleted. Okay, so I'll write S here. But understand this, if the adjacent cells are equal, in that case, the diagonal value will be copied directly. You can verify it for the any value here. Okay, now in this case, we will have to make EA. In this particular cell, we need to make EA and SE equal. In that case, what we'll have to do? We'll have to delete S and A. Similarly, I'll just do a fast forward it a bit. We'll have to delete SAT here. EAT and SE needs to be made equal, so SAT will be deleted. Similarly, SA will be deleted here. Here SA is there, so S will be coming directly. Here, if you see, okay, EAT and SEA, to make them equal, we need to delete S and T. So this is our answer. Now, this is how we approach this particular problem or any kind of dynamic programming problem. We break it into subparts. We treat each problem as an independent problem, and then we make our way forward. Now, talking about the implementation, I'll not take up the conventional approach of opening an IDE and typing it down because it will consume some time. I have written down the code. I will directly you can take a pause here if you need to look at the code and see it. But what I'll do is I'll try to explain line by line what is implemented in the code itself. Okay, how is it implemented? Now we have defined a class here. Okay, we have written a method name minimum delete sum, which takes two values S1 and S2. These are nothing but the two strings. Now M and N are the two values or the two variables which store the length of string 1 and string 2. Okay, now and just understand it like the way we did here. We took the length of C as M and EAT as N. We took the sum, stored the values into M and N, and now what happened is we are designing a M plus 1 plus and n plus 1 matrix, like the way we did here, m plus 1 and n plus 1. In a similar fashion, DP is nothing but an matrix which contains m plus 1 rows and n plus 1 columns. As simple as that, like we did here. Okay, so this is what it represents. Now what we are doing in this particular part is we are putting values in the first row and the first column. If you look closely, we started a loop from 1 until m plus 1. So leaving, for example, if I draw the matrix here, okay, let's take the example of 4 into 4 only. Okay, 1. So it was C and it was eat. I need to draw one more. E A T. Okay, this was blank. This was blank. So ignoring the first cell, we started from here. This is 0, 1, 2, 3. This is 0, 1, 2, 3. We started our loop from the first index going until the third row, and here also we started the loop from first index going until the n plus 1 row till here. Okay, now the dp this m plus 1 into n plus 1 matrix for the first 0th row and first column, that is this one, the 0th row and first column, this one. What it will store is, it will store the value of its preceding cell plus this odd function gives the ASCII value. Okay, so odd of s1 I minus 1. So basically odd the ASCII value of s1 and the ith index is 1 here minus 1, that will be 0. So if it's the 0th value, the ASCII value of s here. Okay, now in a similar fashion, when I becomes 2, the 0th row and second column, this one will store the sum of this ASCII value plus the ASCII value of E, because it will be 2 minus 1, that is 1. The if we talk about C value, this is the 0th index, this is the first index, this is the second index. So E comes at the first index, so it will store the value of S plus E. In a similar, that's why I told you to remember this pattern. Here it's taking this plus this in this cell. In this cell it's this plus this plus this, and in a similar fashion the previous cell plus the current value of that particular column. Okay, in this way we fill both the first row and the first column. Now moving forward, what we are doing is, if you see, we are looping one by one. In the first column, and then column wise we are moving this way, and we are checking. I told you that if the adjacent values of a cell are same, okay, SC and SC are same, we directly import or we directly put the diagonal value. Okay, that's why I told you to remember this pattern. So that is what we are doing here. If the diagonal values are same, directly import or directly put -1, -1, I minus 1, j minus 1 value into that current cell. Okay, else मुझे क्या देखना है, अगर मेरा दोनों वैल्यूज सेम है, अगर मेरी दोनों वैल्यूज एडजेसेंट सेल्स में सेम है, तो मैं डायगनली आई कैन पुट इट डाउन इन द करंट सेल. एल्स मुझे क्या देखना है कि फॉर एग्जाम्पल इस सेल में हूं मैं, ठीक है, तो जस्ट थिंक ऑफ इट, मुझे इस सेल से इस सेल में जाने की क्या कॉस्ट होगी और इस सेल से इस सेल में जाने की. अगर एस ए को, ओके, एस ए को आई नीड टू मेक एस ई ए, उसकी कॉस्ट ज्यादा होगी, या फिर इफ आई नीड टू मेक एस ए टू एस. ओके, इन दैट केस the cost of making SA to S will be easier. So ये चीज, यही चीज I have implemented here. जो current cell की वैल्यू है, minimum of whichever will be there. Okay, minimum of this or this, making this into this or this, that will be put on here. Okay, and in the end, I'll just return the last cell value, the corner cell value, that is SNT. Thank you so much, and I'll be back with another episode.